Hello, everyone. My name is Ahmed. I'm an Android engineer at Careem, and I want to talk to you about our experience with Kotlin Multiplatform. Specifically, so Careem, for those who don't know, is a ride-hailing application, specifically targeting the Middle East area. And specifically, I want to talk about our Kaptain apps. And our captains are, Kaptain is what the term we use to refer to those people working on our platform to drop customers off from one point to another. And as you can imagine, Kaptain app has many responsibilities, some of which is trip management. So where should the captain go? Who should he pick up? Metering, so both distance and the time and the route traveled, and keeping in sync with the backend. But the key point here really is that this app directly impacts the livelihood of captains. So captains, a lot of captains do this as their full-time job, and they depend on it. So if the captain can't work, they're not happy. And of course, that's not good for them because mistakes could negatively affect their earnings. So to kind of start from the end as to where we are today with Kotlin Multiplatform, we have over 25,000 lines of shared code between iOS and Android. That includes tests. We've been in production on Android for a year and on iOS for 7 months. In cities with both the iOS and Android Kaptain apps, about 30% of the captains are on iOS. And the iOS team has 5 developers, and the Android team has 11 developers. But of course, this is kind of the end of the story, so I just kind of want to talk about how we got there, and then kind of talk about some of the lessons and things that we learned along the way. So initially, Careem only had an Android-only Kaptain app, and it was outsourced, so the code was not very well written. They didn't actually have a team that actually maintained it. So modifying the code was very difficult. And there were constantly production issues, captains complaining that things are broken, and we kind of have to figure out what went wrong and kind of fix them. And there was no even good automation scenario where we could actually rely on the fact that any changes we made had sufficient testing so that we know everything is good. So learning from kind of the experiences of others, we knew that we couldn't just stop the world and rewrite. We'd have to kind of do an in-place rewrite. So we began rewriting some of the business logic in Kotlin while within the current app. And we built using Redux-inspired MVI architecture, and I'll come back to this a bit later. And in the meanwhile, we were supporting the existing code base. But of course, what you have to realize is that at this point in time when we started this, there was a new team in place. So there was a lot of fear of, because we're new to the company, we're trying to kind of change things, but there's highly sensitive code. Not very many people know what should happen or what does happen or what works and what doesn't. And there's no good documentation for a lot of this stuff. Around the same time as we're rewriting iOS, iOS came into the picture when business actually asked for an iOS app for captains. So initially what happened is they allocated 1 or 2 engineers to begin rewriting the Kotlin that we were writing, the cleaner Kotlin version that we were writing into Swift. And this quickly became a problem. So it was difficult to keep up with the changes that we were making. Both of us, both the iOS devs and the Android devs, inadvertently implemented bugs, as you could expect, and made assumptions that weren't very obvious. And it was just very tedious in general. Around this time, we proposed to use Kotlin Multiplatform. This was maybe late 2017, early 2018. So when we approached management about this, they were both skeptical and excited about the possibilities of if this actually works, but skeptical because of some of the other stories about some other companies that with different technologies that they've used. And there were lots of unknowns, especially on iOS. Keep in mind this was very early on, so there was no company we could point to that's in production used it, and especially in such a critical environment. And so the way that we ended up resolving this is kind of by having a risk mitigation strategy. So we sort of said like, hey, today, in order to write this iOS app, the iOS devs unfortunately have to look at the Android code somehow because there's no good documentation anywhere for how this code should work. So if they're going to look at the Android code anyway, why not let's try shipping this multi-platform library. If it works, great. If not, this is just plain Kotlin code with no Android dependencies. We can just very easily migrate it to Swift. They're very close to each other. It's easy to do. And so this sounded like a reasonable risk mitigation strategy at the time. So we began by building a multi-platform library. And So we actually started by copying some of these Gradle modules that we were rewriting in the Android app into a new repository. And this library primarily consisted of common code. So a lot of people in multi-platform, a lot of the examples online show an Android app and an iOS app side by side living with the common code. We actually didn't opt for that approach. We took a different approach where we actually built a library. So most of our library is just a standalone library that's then imported by the iOS app and the Android app, respectively. So we worked with the iOS developers to set up and test an iOS build, and we continued migrating code into this library. And in parallel, we kind of extracted out an interface and gave it to the teams so that they could actually start, in the Android case, to rewrite some of the UI, and in the iOS case, to write the UI for the first time. And eventually, we launched, right? So now, I kind of want to shift gears a bit and talk about some of the lessons that we learned along the way. The first one is avoid Android-driven development. Please excuse me because I'm putting on my Android developer hat. This is my, so I'm saying it from this perspective. So for Android developers, it's very easy to convince an Android developer to adopt Kotlin Multiplatform because it's essentially what we're doing every day anyway, with very few differences. And so usually when a lot of these efforts are actually brought up by Android developers and pushed forward by Android developers, but being Android-driven unintentionally can actually cause a bunch of problems, and here are some of the problems we ran into. We quickly noticed some chasms building between the iOS devs and the Android devs, and for many reasons. The first is distrust of non-Swift by iOS devs. And the way I like to think about this as an Android developer is the first time someone tells me, hey, how about you write this app in React Native, the expression on my face will answer more than my answer will. So it's the same thing for them, right? Understanding that it's native helped kind of like, reduce some of these fears. And ultimately, once they saw it working in production, then that kind of cemented their belief in it. Another problem we ran into was that we were inadvertently, unintentionally working in a silo. This caused problems because the iOS developers felt kind of like siloed out and unaware of what we're doing. And to us, we're like, hey, the repo is open, the PRs are open, you could take a look, but they felt siloed. In addition, if you notice early on when I said that I said specifically we copied code from the Android project into the multi-platform lib, and the reason for that was two things, legacy code and the reliance on some libraries like RX. And we at the time, there was no reactive library, there was, and so we were trying to figure out how we were going to address these problems. And so at the time, we just kind of kept a fork, which caused more problems, because we'd update the local copy that lived inside of the Android repo first, and then eventually it would take some time to merge to the actual, what was supposed to be the shared library that iOS team was using. And it was very frustrating for them because they'd be like, hey, we found this bug. And we're like, oh yeah, we fixed that, but yeah, we'll merge it now. So it was frustrating for them. So how did we kind of resolve some of these issues? The first thing was kind of put better procedures for communicating changes. The first is any bigger change, we asked the developers to write a very short document explaining like the architecture of this change, send it to the other developers, give them time to digest it, and just schedule a meeting where people can challenge the idea and suggest better ideas and so on and so forth. The second one surprisingly got some pushback, but in my opinion was one of the best things we actually did. So typically our code review process has been 2 reviews. And as an Android developer working, when I had a PR for the library, I would just turn to my neighbor who was also an Android developer and be like, hey, can you review this? Because it was an easier thing to do. So we put this policy, we said, hey, 1 review per platform on the shared code. And initially the iOS devs were kind of hesitant about this. They're like, hey, I don't really know Kotlin. I don't know if I can actually review this code. But eventually, at the beginning, 1 or 2 of them did. And that actually inspired the rest of them too, as well, over time. And the 1 or 2 that did first were the first to actually contribute to the library, to fix bugs on their own or something like this as well. And then we had a change log with the explicit version changes. So this kind of made it easier to understand what changed between one version and another when we updated code in the library. A couple of things to keep in mind. This might sound very obvious, but iOS developers signed up to work on iOS. And what I mean by this is, there's a piece of this that we actually experienced this actually, where we had one iOS developer who was helping us, migrate some of this code into the shared library. And after some time, they're like, hey, I actually didn't sign up to work on Kotlin. I want to work on Swift and on iOS side specifically. So just kind of saying this to be mindful of the goals of the engineers working in the org and empower engineers to learn and grow. And each engineer wants to learn and grow in a different way. And so, that's kind of, our job to help our colleagues and managers' job to help the people they're managing to kind of learn and grow, but just kind of some things to keep in mind. A couple of the lessons learned from this. So developing a shared library needs a different mindset. This is especially tricky when you're also the customer, because essentially you're trying to wear two hats. I am the Android dev hat, and I'm the library dev hat. And at some point in time, you'll mix it up and you'll wear the wrong hat. You'll forget to switch the hats. And this will cause a number of bad things, like bad code that you don't want in the library that will be in the library, and things like this. So ideal target is that to make your developers your primary customers. And of course, facilitate iOS devs feeling ownership, because especially initially, it'll be very difficult for them to they'll feel like they don't want to contribute or they're afraid to contribute. And you kind of need to help them feel welcome to do so and encourage them. So when we talk about sharing code, the couple of considerations and things there as well. First, what to share. So what we're sharing today, lots of business logic and rules. So actually all our critical business logic about the Kaptain and how the Kaptain transitions from one state to another. It's essentially a state machine that we're sharing behind under the hood, and it's actually core logic and critical logic, critical business logic that we're sharing. Also, the troubleshooting and bug fixing. So this was actually when you start to feel the fruits of your labor, is when the iOS devs are the ones who find a bug, and they find that the bug is in the library, and they fix it, and you get the fix as well for on the Android side, which was awesome. And tooling. Tooling is something we want to invest much more into, but there's huge opportunities for sharing tooling as well once you're actually sharing some common code as well. So some general sharing tips. A lot of people ask, what should we share? And in my opinion, the answer is it's tricky, it depends. But if you have to give an answer, share as much as possible. But really, the answer should be share whatever developers on both platforms are comfortable using. And again, going back to the analogy of React Native, so as an Android developer, if I'm applying for a job and they say, hey, our Android app is 100% React Native, that could impact my decision as to whether or not to work on this app or not. So similarly, if you say, hey, we're going to share UI, we're going to share everything, it could also impact an iOS developer's decision to work or not. So share what both are comfortable sharing. Start with what you can agree on, and build trust from there. And this always applies, but study open source libraries and carefully decide whether or not it makes sense to use them at this time or not. Because the reason I point this out specifically is because the great thing is there are lots of new open source libraries all the time that are being built, and those save a lot of time. But initially, some of them might not be very stable, for example, and so there's a risk factor involved. So you have to decide how much risk is acceptable depending on each case-by-case scenario. When we talk about code sharing, we inadvertently talk about dependencies. And there are two primary ways to share dependencies. The first is expect actual, where in the Kotlin Multiplatform code, you have an expect class saying that the date has a current time. And on the Android side, you implement it saying, OK, this just returns the current time in millis. And on the iOS side, you say, OK, this is the corresponding call in iOS, which is time interval since 1970. So a couple of points about expect actual. The iOS implementation must be in Kotlin. And so this might not be convenient in the sense that most likely the people doing the iOS implementation are iOS devs. And so you're asking them to write the iOS logic in Kotlin, whereas it's much easier for them to just write it in Swift. The other consideration is the implementation sometimes, because of the interop with Objective-C, might not even look like pure Kotlin that Android devs, for example, are used to. So due to things like allocations and memory scoping and things like that, like some of the code ends up looking a little strange. And so just some points to keep in mind. The other approach is dependency injection, and this is what we do very heavily. An example of this would be I have an interface in the Kotlin multiplatform code with some methods there defined. On the Android side, I just implement this interface and delegate to some repository. And I can use Dagger as usual, and everything is as usual as normal on the Android side. So I'm just delegating to that repository to kind of get these results, right? And on the iOS side, it's very, very similar. They're delegating to this booking configuration object to get this result, and they're also implementing the same interface. Now, when I actually want to use this in the Kotlin shared code, I can use it something like this. So I take the actual configuration object as a parameter to my class, and I just call it exactly like I would expect to call it. The only difference is that when I'm creating this sample command from the iOS side, I'll just pass in the iOS implementation of the class, versus from the Android side, I'll pass in the Android implementation. Shifting gears a bit to talk a bit about architectural considerations. So first, kind of suggestion, I guess, is limit the impact of changes on the SDK layer. And we kind of learned this the hard way on the Android side, where the iOS side actually did it a lot better. Because of the fact we were actually moving classes out of the Android code into the shared library, we actually for example, moved some of the core booking data classes, which are actually used all throughout the app end to end. Whereas the iOS side said, you know what, we'll create our own local one and we'll map between this one and the other one. And you can imagine whenever we needed to actually change that data class, you can imagine the headache it was on Android because it affected all the code end to end. But on iOS, it was much easier because there's just one mapping function you had to tweak and everything was same as normal, right? So ideally restrict usage of the library to a handful of classes and expose alternative interfaces to the rest of your code so that it makes it easier to adopt changes. Another point is consider whether or not sharing architectures between platforms makes sense. So this is kind of a, you know, there's a difference of opinion about this, but some companies have had success in sharing the same exact architecture between iOS and Android. And just it's a point of consideration of whether or not it makes sense for your company or not, because inadvertently, your library, your multi-platform library could impact the architecture directly or indirectly. And I kind of want to give an example of this. So I mentioned earlier on that Android library, we initially started with building it as MVI. So when we think of MVI, we think of a stream of states that is observed to, that is subscribed upon, and when changes are observed, some changes on the UI are made. So first off, how we actually did this in multi-platform. So there's actually this neat method in the standard lib, delegates.observable, which essentially just calls, every time your setter is called, it'll just call whatever is in the lambda. And in this case, this is just an interface on a booking state listener is just an interface, which again, in the same way that, that I showed earlier, will just be implemented by iOS and Android so that they can handle anytime the state is changed in this case. Even if this multi-platform, even if this library method didn't exist, you can do the same thing by just calling a method whenever the setter was called. So on the Android side, you'd implement the listener, for example, creating a subject and on state changed, emitting on next, and exposing a stream by hiding the subject or whatnot. One point I want to point out here, something that we found very useful both on iOS and Android side is type aliasing. So if you notice, the class name is booking state listener, but the interface name is CME booking state listener. And so what we did is we gave a name to all the objects coming from the shared class. We prefixed with CME, which stands for Kaptain Mobile Engine. And so we type aliased it. So even though the class name is actually the same, but because of the type alias, like it's cleaner to use this way. We do this both on iOS and Android sides. The iOS code, again, is very similar. They create their own subject using RX Swift, and again, emit on next whenever the method is called, the function is called. So that's how we observe changes when things change, but how do we actually make changes? To make changes, we just call methods on the library, as you would expect, to just make changes. So using an example, if you were to open an app and request a ride, what would happen is something called a booking offer is created. And this booking offer is sent by the backend to the number of captains, to a number of captains who are most ideal to accept your request. And if a captain, when the captain sees the offer, they can choose to accept it. And when they do, one of two things can happen. Either it can be assigned to them, or it can expire. And expired really just means that either someone else got it, another captain got it, or maybe the customer canceled and backed out, for example. So you can imagine on the Android side, someone clicked the button to accept the offer, and you're just calling this method on something in the shared code on booking offer accepted. And you're subscribing somewhere to this observable of booking states, and looking for a change in the assignments. And whenever something like this happens on the UI thread, for example, you do whatever UI makes sense, UI change makes sense, and the same for expiration. The iOS devs actually wanted to do it a bit differently. So they didn't want to actually be subscribing one place for the assignment and somewhere else for the expiration. So they kind of wanted to do it a bit differently. And what they really wanted was they wanted a function called accept, where they would give it the offer, and it would return back a booking if it was assigned, or it would throw an exception otherwise. And so they opted to write a layer on the iOS side to kind of manage this. So the way this kind of looks like, I know it's a lot of code, but I think it's not. I think the important part is, so they have a piece that's watching for changes of expiration, and whenever such a change happens, they just throw an exception. And another change for watching assignments, and whenever such a change happens, they map the booking object from the library into the iOS booking object. And then they create an observable where they first accept the offer, and then they wait for the first thing to come back, whether the assignment comes back or an exception is thrown, and that's it. And so they just return a single booking. So the reason for this example and kind of talking about this is just saying be intentional about the impact of the design decisions that are made inside of the multi-platform library on iOS and Android. You can imagine in a case where if the architecture on iOS was much, much different, the way that we structured the architecture on Android might have made it difficult for them to actually adopt it. But because things were similar enough, it was straightforward without actually changing the library to kind of adopt what both sides wanted to do. Shifting gears a bit and talking about platform differences. So not everything is analogous between Android and iOS, as you can imagine. So on Android, for example, you can actually request a fuse location, or you can request GPS location, for example. And we're actually requesting both and doing different things with both of them. But on iOS, you just get a location from core location, and you have no control over where it's coming from, for example. So just something to keep in mind, right? So other things to consider is the fact that infrastructure or libraries may differ. And these are things that we kind of take for granted, or we took for granted at least. So just a point of heads up. So for example, on Android, some of our jobs we're using Work Manager, and we kind of treated them as kind of fire and forget. And we knew that if it failed, it's going to retry in the background silently and so on and so forth, using exponential backoff and whatnot. But we didn't communicate this to the iOS devs because we're like, oh, they must be doing the same thing. But they actually weren't, because how would they know, right? We didn't tell them. And so it just happened when they said, hey, how are you handling errors in this case? We're like, oh, our work manager is doing that for us. So just kind of something to keep in mind. And actually, one more point about this. Actually, even other things like push notifications, which are the same feature which are similar on both iOS and Android, there's different capabilities of the platform that might be available to Android that are not available to iOS, for example, and vice versa in other areas. So just something to keep in mind. I want to shift gears a bit and talk a little bit about code organization. So again, I apologize, Android developer hat on again. So Gradle modules, as in an Android world, we know makes a very good basis of separating business logic and helping achieve kind of faster development and testing time, less conflicts between developers, and less contention on the classes that are being changed. And we can use something like the internal keyword to kind of encapsulate certain classes within a module, but not expose them outside that module. So Gradle modules are great. But so what does this have to do with iOS? So on iOS, the target is to have a single framework, a single multi-platform framework. And this is because of current limitation in multi-platform. So building a single framework from a single module is very straightforward. And even from a repository consisting of multiple modules, Gradle modules, it's also straightforward. But when you actually have multiple repositories, things become a bit tricky, especially if you do what we did initially, which is use submodules, because we're like, at the time, we didn't really have another option. So keep in mind, this is before the new Kotlin Multiplatform plugin, which I guess is not new anymore. But so before this, that's actually what we were doing. So we had a submodule one library had a, even though there was no code dependency between the two libraries, there was the submodule dependency so that you could just build the iOS framework at the end. But with this, with the new Gradle plugin, it becomes very straightforward to have multiple repositories with multiple modules in each repository. And so what happens is each of these Gradle modules will build an artifact. This is what we're used to on the Android side, where you get jar files on Android from each module, and you get klibs for iOS, one per architecture. And so then what you can do is you push them to Artifactory or Sonatype somewhere in Maven where you can use them. Now, once you have this, now to build the iOS framework, what you need is just a single Gradle file somewhere, which is kind of like a monolithic Gradle file that's kind of pulling in all the dependencies needed and builds the final framework. And a snippet of this kind of might look like this. So you might notice that we're depending on Careem Kaptain dependency 1.0. So the nice thing is, first off, it's versioned. Secondly, I don't actually have the library code here. I left the project one as an example, but all of these live in Maven, right? So the other nice thing is changes to the shared code cannot break iOS unless they change the version number. So this is kind of a nice thing. A couple of notes. So this monolithic module I'm talking about has to have at least one source file in it, even if that source file is empty and just declares an object or something, because otherwise it won't build. I think this will be fixed sometime in the future. Classes are namespaced with base name and Objective-C. So you might have noticed the base name that you can specify in the module. This actually ends up just prefixing the different class names. If it's not there, it uses the Gradle module's name. And in Swift, classes are not namespaced. So duplicate classes from different modules will have their names changed. So why would you have duplicate classes from duplicate modules? So the fact is, on Android, we can have two classes called core, but they live in different packages. And that's completely fine on Android. But on iOS, there isn't this concept of packages. And so consequently, if you have two classes called core, they conflict. And so what Multiplatform does is it renames the classes so you can actually use both of them. So in Objective-C, so remember the base name prefixes the class name, so you'll have like base core and base core underscore. And in Swift, you'll have core and core underscore. So just something to be mindful of. Just be careful not to duplicate names, because otherwise you're trying to use one of them, but you're actually using the other one, and which one, and like the fact that it ends with an underscore might be a bit tricky. So just something to keep in mind. The other point is export is not transitive by default. So if you export a dependency, any dependencies of that dependency, iOS will not be able to see. So you can set this flag if you want it to be able to see those dependencies. Shifting gears a bit to talk about a couple of notes about building for iOS. So some things are lost in translation. So because of the fact that interop is with Objective-C instead of Swift, a couple of things are lost in translations. One of the things is default parameter values. So both Swift and Kotlin have default parameter values, which are really great, but not in Objective-C. So consequently, something like the copy method, it's there, you can use it, but you have to pass in all the parameters to it. So it's a bit of a hassle right now. The other thing is generics. So, but things are getting better. So imagine you have this class. So this is just a node of any data type T, and it has a value, and it has a next node. That's it. So imagine I add this into my Multiplatform library. What gets generated in the header for the framework is this type ID. And ID is really like any object, essentially. So it doesn't actually realize that it's generic. So when you actually try to use this in Swift, it says, hey, this is not a generic type. You can't do this. Similarly, you might think like, hey, maybe it's because of the T. Maybe if I don't make it like, maybe if I actually like tell it that like, hey, this will be a node of a car, things will work the way I expected. But again, in this case, I expect value to be a car, but the error is value of type any it doesn't know that it thinks that it doesn't know what type it is, right? So you actually, without explicitly casting it to a car. But as of Kotlin Multiplatform 1.4, Kotlin native 1.4, thanks to the work of the TouchLab team, they added a patch to have better Objective-C generics. So when you enable this compiler flag, what happens is essentially you can see that the ID got replaced with T here, which is kind of what we want. But one kind of thing that we didn't expect is that it's marked as nullable because our initial field wasn't nullable. So now it works, but it's a different error, which is saying like, hey, this value type is nullable. You have to unwrap it. So you actually have to do this for it to work. But essentially, it's working. The reason for this happens to be because of the interop, because of the interop between Objective-C and Swift. So Kevin has a really good blog post where he explains this in great detail. I highly recommend checking it out if you're interested. But essentially, the fix is to just set an upper bound on T to be any. And if you do that, then you get what you would expect. So init with value, type T value. And then, the second example works as expected as well, where it understands that it's a car. So a couple of difficulties. So debugging between Kotlin native and iOS is difficult. TouchLab, again, has a Xcode plugin that helps with this called Xcode Kotlin that you can check out. And also, like I guess as we heard in the keynote today, hopefully there are some things to look forward to in the upcoming year. Symbolication is only there for debug builds. Symbolication is important because that's how we know when a crash happens where it happened. It's experimentally there for release builds in 1.3.6.0. And also very recently, the TouchLab team released a library called CrashKit iOS that actually makes it easy for when a crash happens, you can actually identify also where in the Kotlin code the crash happens, as opposed to just knowing that the crash came from the Kotlin code. I want to talk a bit about multithreading. So coroutines are single-threaded on iOS, but not for long. So there is an EAP version that supports multi-threaded coroutines. And I think there are some apps pushed out that actually use this, especially by TouchLab. But at the time we were building this, so early 2018, there were other options like workers and so on, but we opted to actually multi-thread with delegation and interfaces. So the way that this could look like, or this looks like, is, for example, I have this interface called the booking interactor. And it has a function called handle booking, which is just going to do some kind of network call, for example. And what we pass in is a callback and say, hey, when you're done, just call me back. Give me an error if you have it, or otherwise give me null, in which case I know that it succeeded. Then you can implement this on the Android side. And on the iOS side, you can implement it as well. So you can see here that creating some kind of endpoint, you can imagine service is some kind of network service class that will take this request, execute it, and call the Lambda on the correct thread to do whatever is inside the Lambda, which inside the Lambda will just say, hey, did an error happen? Is this result an error? Is it failure? If so, we'll just create an error. Otherwise, there's no error, and we'll call the callback. Interestingly enough, this code actually was crashing on 1.3.5.0 because of the fact that in multi-threading, access to all mutable objects needs to be single-threaded. So kind of like the core rule of multi-threading is that objects can either be immutable, in which case you can share them across threads, or they're mutable, in which case only one thread can use them. And so this includes object creation, using the object, and releasing the object. All three of these have to happen on the same thread, on the Kotlin native thread. And what was happening, the reason we had the crash there, is because what was happening is, even though we called the callback on the correct thread, after this, Swift was deallocating the Lambda. And our callback still existed there. So it was trying to deallocate our callback as well, but not on the same thread, on a different thread. And that was what's causing the crash. So this was fixed in 1.3.6. But before it was fixed, the other way that you could work around this was just nulling out the object before you return back from the call. And then this way, when Swift actually deallocates the Lambda, it doesn't deallocate your object as well. And another way we could have fixed this probably, but I guess we didn't realize at the time, was to just freeze the Lambda. And we actually realized that, but we didn't do it because we had one mutable variable. And what we didn't realize at the time is that we could have just changed that mutable variable to an atomic reference, which is available on both platforms, and would have just solved the problem for us. So things that we're thinking about at Careem and like we're thinking about now. So our library tests are currently JVM only. And the reason for that is we use mocks heavily. Mock-K doesn't support multi-platform yet, though there's an issue there. And so hopefully we can hope for that sometime in the future. We should have used fakes probably, but we didn't. So, what more can we share besides business logic? Really, the thing I love about this point is the fact that the ideas of things that we should share now are more often than not coming from the iOS developers. So because they're the ones that wrote the newest app, their feature set is less than the feature set available inside of the Android app. So they're like, hey, we want to do this. Is this available? We're like, no, only in the Android app. They're like, hey, what if we just build it inside of the Multiplatform library? And this really made me happy because like it shows that after some time, even though there's resistance initially, when they see it working, they're sold on it, and it just makes everybody more productive. Another point is how do we avoid inheriting technical debt? So again, because sometimes we end up migrating from, let's say, the Android feature into the shared library, things end up there that really shouldn't be there. And they're really just there because, oh, Android uses this thing. But really, if you think about it, why is Android even using it? Nobody asked the question for so long, and nobody really knows. So how do we avoid kind of inheriting more technical debt when we're doing this kind of work? I mentioned before common tooling. So one of the interesting things that we wanted to do, and we kind of did a little bit, but we wanted to do more. So I mentioned MVI. We actually log in a very similar format so that in production, when a problem happens, we can just kind of look at the log and understand exactly at which state transition things failed. And you can imagine kind of if we actually are sharing tools, we could actually write a tool very easily to replay exactly what a captain sees on a trip. And not only just have to like scour through the logs to figure out what went wrong, but we can actually visually see it if we actually invest more time into things like sharing common tools. And finally, multi-threaded coroutines. So again, this is going to be huge. It's going to save us a lot of time. So we're super excited about this. So in summary, avoid Android-driven development. Communication is key. It's very important. Give a sense of ownership, especially to the iOS devs, and encourage their participation. Treat your developers as customers, as opposed to treating the app that you're working on as a customer, especially in the cases, by the way, the reason for the whole, in an ideal world, we would have a set of developers that are actually developing the app that are not working on Android and that are not working on iOS. But we didn't have the resourcing to do this. And so we had to take the resourcing from within the existing teams, which is kind of why this ended up happening. But if you're in that position, just make sure you treat your developers as customers. Architect for success, share what both platforms agree on, and then you can build from there. Limit the impact of the shared library on the code. Be aware that the architecture could potentially influence both platforms. A couple of other lessons. Multi-platform can be as risky or not risky as you want. And this is kind of the key. Like a lot of people are like, it's not ready yet. I don't know. But actually, things like the standard lib are like rock solid. And people are using them in production now, and even for mission-critical apps, and they work great. Now, if you're trying to use multi-threaded coroutines in production now, well, chances are you'll find a bug. It's still an EAP. It's not even marked as stable yet. So just keep in mind, something to keep in mind. But in general, start small and expand from there. So build trust, and with time, this trust basically allows you to increase your impact. Invest in building and supporting open source libraries, because now is the time. Like now it's a beautiful time, because as more and more people are adopting Kotlin Multiplatform, there's a huge opportunity to build open source libraries and invest in them, even if it's just reporting issues when we see them, things like that. It just kind of makes the ecosystem better. One final summary, and small by the way, like we're hiring and we're doing a lot of cool projects. So if you're interested, come talk to me. So I just wanted to summarize all of this in a rhyme. So for engineers at Careem, multi-platform was just a dream. Kotlin Multiplatform made it true, and it can work for you too. We share on Android and iOS. Our code is clean and not a mess. Business logic is what we share while showing our iOS devs that we care. Most of our code lives in common main to keep our dependencies nice and sane. Dependencies implemented on the platform side, we use Dagger on Android with nothing to hide. On Swift, we roll our own DI. I speak the truth and do not lie. We build libraries and version them too, updating a changelog with whatever is new, push them to a Maven repo to use, and add a tag with nothing to lose. Klibs are uploaded on iOS, jars on Android without a mess. The clients use them as you'd expect. And best of all, bugs that we detect can be fixed on both platforms with ease, saving us half the development fees. With multi-platform coroutines coming soon, the limits are really beyond the moon. So if you haven't considered sharing code, it's a good time to get into this thought mode. That is all I have to say. I hope you enjoyed this talk today. Thank you.